Welcome. In this video, we are going to use this graph below to determine which vectors are equivalent. And I just want to quickly point out that some texts refer to this. Well, they refer to this as equal. And remember, when we're looking for equivalent vectors, what we're looking for is twofold. Well, two things. We want them to have the same length, same size, or the same magnitude. And we want them to point in the same direction. So just by inspection, I can tell, as far as the same length goes, C, D, and F are out. They don't match the length of any other vector. And if you don't see that, sketch a right triangle. The length of C, that is the magnitude of C, is equal to 3 squared plus 1 squared, so 10. And let's look at the magnitude of F. Well, the magnitude of F is equal to 2 squared plus 3 squared. So 13. They're not the same length. And you can do the same with D. So C, D, F do not have a magnitude equal to any other vector. So these are out as candidates, and I'm going to cross them out. There. Okay, so let's look at the rest of these vectors. So just by inspection, I can tell they all have the same length. That is, they all have the same magnitude. And you notice if I make a triangle here for A, what is the magnitude of A? Let's actually go ahead and just do this. Oops. Okay, so if I want to look at the magnitude of A, well, that's going to equal 1 squared plus 2 squared, so 5. Well, what about the magnitude of B? Its base is 1. Its height here of this triangle we can form is 2. So it also will have a magnitude of 5. So I know that this is also equal to the magnitude of B, which is also equal to the magnitude of E. What else? Let's look at H and M. Again, H is very similar, a base of 1, a height of 2. M has a base of 2 and a height of 1. So let's look at this. M is equal to 2 squared, the magnitude of M is 2 squared plus 1 squared is also equal to 5. So look at this, they all equal 5. This is equal to the magnitude of H as well. So A, B, E, H, and M all have the same magnitude. And this magnitude is 5. Now we just need to determine if they're equal. So we know they have equal magnitude, but there's more we have to do. We have to see if they point in the same direction. So see if you can figure out which of these vectors point in the same direction. Okay, well, based on the grid, we can tell that A, B, and E all point in the same direction. H points in the opposite direction of A, B, and E. And then finally, M points in its own direction that is not the same as A, B, and E, and it's not opposite like H is. So if you can see, here's M's direction, here's H's direction, whereas A would overlap with B, and E would also overlap with B. Okay, so we have our equivalent vectors, or our equal vectors. Before I go on, I need to fix this. I wrote a 1 here. This should be 2. We were looking at criteria 2 here. There we are. Okay, so vectors A, B, and E are equivalent. All right, keep calm and math on.